So we're going to start with the pH scale on this page. So it says properties of acids and bases, and so the pH scale will go from 0 to 14. And then halfway between 0 and 14 is going to be a 7. And so we'll go from the middle first. I'm going to use like this color. So a 7 would be what we call a neutral solution. So I'm going to go ahead and put down here where it says pH scales, 7 is neutral. And the example that I always go to for this one is just water. So a lot of things are really close to neutral, but water is like true neutral, just normal water. And then something that has a pH of lower than 7 is considered an acid. So an acid's pH range is from 0 to 6.9 is technically an acid. The further away from 7 that you are, the stronger it is. So a strong acid is going to have a really, really low pH, like not quite 0, but maybe like closer to 0. And then more weak acids have a pH of like almost 7. But anyway, in here, between 7 or between 0 and 7 is going to be an acid. And then anything with a pH above 7 is going to be considered a base. So a base has a pH between 7.1, since that's higher than 7, to 14. So higher pH is a stronger base. And again, the closer you are to neutral on either side is a weak one of either one. So for example, an acid with a pH of 6.5 or a base with a pH of 7.5, those are both going to be weak because they're both close to neutral. And then the rest is all going to be characteristics and then how we see these on in indicators. So I'm going to just use red first for acids. So starting with acids, the taste of an acid is generally going to be sour. I'm not suggesting tasting acids, but some things like citrus, that's very acidic. And so if you're familiar with the taste of an orange or a lemon or a grapefruit or something like that, that's sour. So I'll put that in my examples. The reaction with metals is that an acid in the presence of a metal is going to produce hydrogen gas. Acids are great conductors. And then the texture of an acid, what it feels like when you actually touch it, is just water. So you're not going to be able to tell that something is an acid generally by touching it. If you had to guess, would an acid have more hydrogen ions or hydroxide ions? Based on the definitions we've learned so far. An acid is going to have more hydrogen ions. And then with litmus paper, we generally will use like the opposite things litmus paper to indicate what something is, because if I have something like red litmus paper, it will still be red in the presence of an acid. So it turns / stays red. Versus blue litmus paper will turn red in the presence of an acid, and that is more noticeable, that's more telling. So that's a better way to indicate that something is an acid. Letter C is Hydrion paper. This will indicate both ways, and this also turns red in the presence of an acid. And then as soon as you feel like you understand the pattern, something different. Cabbage juice is actually a really good indicator of acids and bases. It will change color, but instead of turning red, it turns more like pinky. Not quite this kind of pink, but I guess we'll write that. So it turns pink, which is kind of in the red family. And then phenolphthalein, this last one, is an indicator, but only for bases. So I'm going to actually write that down. Zoom and write it, if it'll zoom. So phenolphthalein will only indicate bases, and the reason for that is that phenolphthalein is colorless, which is clear, when it's in the presence of an acid, and it's clear or colorless when it's in the presence of water. So you can't tell the difference between an acid or water when you're using phenolphthalein as your indicator. And then some examples of acids are, like I said, citrus. Any kind of citrus I would consider acidic. Soda generally would contain some kind of citric acid. Vinegar is an acid. Anything that has acid in the name, you can probably trust it that it's an acid. So like stomach acid or battery acid, those things might not have like a chemical formula that we would know how to name based on the naming conventions that we have, but if it says acid, that counts as an acid. I almost just wrote acid again. Stomach acid. Stomach acid is basically hydrochloric acid. I think it's got some other stuff in there too, but stomach acid, battery acid. All that. And then the next column is for bases, so it doesn't really line up with our pH scale up here, but next column for bases, so I'm going to switch my pen color to blue. The taste of a base is going to be bitter. So what I think of with this is like soap. If you've tasted soap, you know, like the bitter taste, like it's not sour, it just kind of like, I don't know, feels weird in there. Any kind of like cleaners are generally bases, bleach. What? Is it who tasted those? Have you never tasted soap? No, not on purpose. I'm not condoning tasting soap. Well, I don't know that I have never tasted bleach that I can recall. Again, not suggesting any of this. I'm just saying, like, you ever been like washing your face and accidentally gotten some soap in your mouth?
I keep my mouth feels like tight.
Well, when I was younger, we used to get our mouth washed out with soap if you said something bad. They would put soap on your toothbrush and then it was terrible because then after that, when you'd brush your teeth, like you'd still have like soap residue, you know, in your toothbrush bristles. Yeah. Did y'all not do that? Is that not a thing? I would like it though with hot sauce. All right, no, we're not going into punishments. All right, come back to this. Okay, bases are not going to react with metals. In general, it's going to be no reaction. This will be lovely. We're recording this, so it's going on the channel. And be like, oh, my dad beat my butt with a belt. As far as conductivity, the conductivity of bases is kind of all over the place. Sometimes we say that it's good. Sometimes we say that it's okay. Sometimes we say that it's poor. The texture of a base, if you think about like what it feels like to hold soap or to hold a cleaner, like if you get cleaner on your hands or something, or get bleach on your hands, again, I'm not suggesting doing this, but I'm saying you can feel that it's like slippery. It doesn't feel like water. Maybe this is how we get y'all to wash your hands. Oh, I don't know what soap feels like, and then we practice. Yes. We're not going to answer that right now. We could, but we won't. And do bases have more hydrogen or hydroxide ions, do you think? Hydroxide, good. I shouldn't have reminded you that I'm recording it, because now you're going to be like, let me get on the channel, miss. How many of you have subscribed? Look at this. This is for you, the real fans. All right, the indicators. The reason I switched to blue is because basically the same kind of pattern that we saw with the red for acids is what we see for blue with bases. So red litmus paper in the presence of a base is going to turn blue. Blue litmus paper in the presence of a base turns or stays blue. What do you think the next one do? This Hydrion paper. Perfect. And then cabbage juice, I'm going to switch colors just so it stands out a little bit. It's not the same kind of blue, but it's sort of like blue-green. And then phenolphthalein turns like fuchsia, bright, very noticeable pink. So not this kind of pink, but I don't have a good match. All right, and then a neutral solution, we're just answering all of these same things for water, so it should be pretty straightforward. What is the taste of water? Nothing, no taste. The reaction with metals, like if you just take a piece of metal and you put it into water, nothing's going to happen. It's no reaction.
It tastes like metal. Why do it taste like water? It's cool water.
What?
What makes the metal rust?
Oxygen. Rust is formed between iron and oxygen. But it's usually oxygen, like, you know, in humid air or something like that. Yeah. The conductivity of water is that it is not conductive. So if there are not ions dissolved in your water, if you have just pure water, where honestly a lot of our water is not just pure water, the stuff that comes out of our sinks here, the stuff that probably comes out of your sink at home, the stuff that comes out of the water fountain is not just H2O. There are usually dissolved ions in the water, and that's totally normal. So our tap water in general can kind of conduct electricity, but pure H2O will not. All right, just a little bit more to get through. Please stick with me for a little longer. The texture feels like water. So if you put your hand into a thing of acid and you put your hand into a thing of water, it's going to feel the same. You're not going to be able to feel by the texture of it. And then this question, my 7th period kind of struggled with. Let's see if y'all can get it. Would water, remember that water is H2O. Or we also write it as HOH. Would water have more hydrogen ions or more hydroxide ions? Raise your hand if you think hydrogen. Raise your hand if you think hydroxide. Would water have more hydrogen ions, more hydroxide ions, or neither/both? Raise your hand if you think that they are perfectly equal all the time, every single time. Be confident in your answers, you guys. All right. Okay. So water. Look at our formula for water. I have HOH. So for every single hydroxide ion that I have, how many hydrogen ions do I have?
Oh,
What? Hold on. Whoa.
what happened for you?
Okay. Let me give myself some more space to write. I'm gonna go down here. So if I write water as HOH, right? You with me so far? This is made up of how I got this is by taking a hydrogen ion and a hydroxide ion. So even though there is a hydrogen as part of hydroxide, if it's part of this ion, it is only considered a hydroxide ion. This is a hydrogen ion, always has the plus charge. That's an ugly plus, but whatever. And then hydroxide is always a negative. So if I have this, do I have more hydrogen ions or more hydroxide ions? Or neither? Neither one. Why?
Because they're the same.
It's the same. It's exactly equal every single time. For every one hydrogen you have one hydroxide. That is the formula for water. So neither equal.
HOH, that's hydroxide, and then hydrogen, which is just hydrogen. And then it's just like 1 for 1.
Equal. So if they are exactly equal to each other, that is water, that is neutral. If you have more hydroxide ions, that's going to be a base. If you have more hydrogen ions, that's going to be an acid.
Okay.
Make sense? Cool. And then as far as the indicators, if you have red litmus paper and you put water on it, what ends up happening is it just looks like wet red paper. So if you can imagine like taking a piece of construction paper, for example, and it's red and you spray some water on it and it kind of looks like darker red just because you can tell that it's wet, that is exactly what happens when you dip red litmus paper into water. So turns / stays red. Was there a hand up? Or did you get your question answered?
It was Catherine.
Okay. Blue litmus paper. What do you think happens to that?
It stays blue.
It's darker blue.
Exactly. So it's just like what I said with the construction paper. If you had blue construction paper and you put water on it, it's just going to look a little darker blue, but it's not really changing colors. So turns / stays blue. Letter C, for this Hydrion paper, this is why I chose the color that I did for this column. It turns like a yellowy orange, so actually I'm going to use this one. And then letter D, cabbage juice. The cabbage juice already is purple, and then it will just kind of turn like a watered down purple. Like if you took Kool-Aid and added more water to it, it's going to just get lighter, but it's going to be that same color. So light purple. And then, like we already said, it will be colorless in the presence of phenolphthalein, or phenolphthalein will be colorless in the presence of water. And then we have already filled out all of the examples and the pH scale, so make sure that you've got that all in your own notes.